So welcome back guys. In this module we will learn about L2 routing. So we will discuss L2 routing, that is the routing that is done at a data link layer. So remember, L2 routing is done at a data link layer. When we talk about L2 routing at a data link layer, only MAC address is used to deliver the packet to the destination machine. It means only MAC addresses are responsible to take your packet from the source to the destination machine in L2 routing. There is no use of IP addresses in L2 routing. It is for this reason that IP addresses are also called network layer address or L3 address or network layer address, IP addresses, whereas MAC addresses are called L2 addresses because L2 routing is done only using MAC addresses. Once the packet has received from the outside world to L3 router, thereafter packet is delivered to destination machine in a subnet using MAC address only. So you can see in the diagram, the machine A, B, C and D all are present in the same subnet. Let us call this subnet as A, the subnet A, and the network ID of this subnet is 11.1.1.0/24. Now if the machine A wants to send a data packet to any other machine in the same subnet, let's say in our example machine A wants to send data to machine D, then only it can send the packet to the machine D only using MAC addresses. It do not require the knowledge of IP address to send a data packet to any other machine which is hosted in the same subnet, right? So L2 routing means routing within a subnet. Routing within a subnet means source machine and destination machine both are present in the same subnet. L2 routing also means that the directly connected L3 router, that is L3 router which is directly connected to the subnet. If this router wants to send a packet to any other machine which is directly connected to the subnet, then that also comes under L2 routing. That is sending a data by a directly connected L3 router, it is L3 router to any machine which is connected to a subnet, and that subnet is also connected to L3 router directly, then that type of routing also comes under L2 routing. So in this example, suppose if the L3 router wants to send a data packet to machine B, then it is L2 routing, or it wants to send a data packet to machine C or D or A. All are the examples of L2 routing. Next we will discuss L2 header and Ethernet header. But before that, let us discuss some basics. So router, here whenever I say router, it means L3 router by default. Router are always L3 devices. L3 devices means router works at the network layer. So in this example, you have a subnet A and you have subnet say B. The network ID of this subnet is 11.1.0/24 and the network ID of this subnet is 10.1.0/24. Now if a machine A wants to communicate to machine C, for example, it is L2 routing. But if the machine A wants to communicate to machine E, now machine E and A are present in different subnets, right? So L2 routing cannot redirect your packets from source machine A to destination machine E because they are present in different subnets. So here we need L3 routing, and because we need L3 routing, we need an L3 router, right? So a machine present in one subnet cannot talk to any other machine present in other subnet without L3 router. So L3 router is required if you want to send a data packet from machine A to machine E, and both the machine, that is source machine and destination machine, are present in different subnets. So different subnets means L3 routing, same subnet means L2 routing. This is L3 routing and this is L2 routing. So router is a gateway to a subnet. Gateway means any machine present in a subnet, if that machine wants to send a data packet to any other machine which is not local to that subnet, then L3 router has to be used as a gateway. That is, the packet has to go to the L3 router and then that L3 router will redirect the packet accordingly. So we will discuss this whole process in detail when we will be learning L3 routing. Currently, we will restrict our discussion to L2 routing only. So L3 routers are the boundaries of a subnet. So this is important, that you have a subnet A. So the boundary of this subnet is L3 router. You have a subnet B and the boundary of this router is again L3 router. Right? So L3 routers are the boundaries of a subnet. The next thing that you should understand is the protocol identifier field. Now, every header in the packet has to provide the mechanism to convey what is the next header following the current header in the packet. Now, your packet contains the following header: the data link header, IP header, transport header, and then application data. Now, you can see that the fields in bold in each of these headers are some special fields. Special field means these fields contains information such that that information conveys that what is the next header following the current header. For example, the data link header, the type value is 080. If the type value is 0800, it means that the next header is the IP header. In the IP header, there is a field called protocol. If the protocol value is say 17, if the protocol value is 17, it means that the transport header being used is TCP, right? And I don't remember the value of UDP. If the UDP protocol is being used as the transport header, then I think the value of the protocol value will be 6. If the value of the protocol value is 6, then the transport header being used is the UDP. Then transport header has a port number. The port number uniquely identifies the application which is running on the machine, and that application is interested in receiving a packet in which the port number is specified. For example, in transport header, suppose the port number is 8. So any application which is registered with port number 8 will receive this packet. Similarly, in the transport header, if the port number is say 20, so port number are just an integer value. So if the port number is specified 20, then there must be some application running on the machine which is listening on port number 20. And whenever a packet arrives such that the port number in the TCP or UDP header specified is 20, then your transport layer will hand over that packet to that application which is listening on port number 20. So you can see that every header contains the knowledge which says that what is the next type of header following in the packet. The outermost header is the data link layer. Also, you can see that there is one-to-one correspondence between the packet headers and the TCP IP stack layer. If the packet header is data link layer, then this header belongs to data link. Similarly, if the packet header is the IP header, It means that the packet is operating on the network layer. Or in other words, we can say that the network layer header is an IP header. IP header is not the only example of network layer header. The other header is IPv6 header, which is again a network layer header. Similarly, the transport header. Now, the two famous transport layer protocols are TCP and UDP, right? So, both of these type of protocols falls under transport layer, and the transport layer has a header called transport header. So, whenever you say that you have a transport header, it means you are operating on transport layer, and then you have the application that is running at the top. So, we will discuss the Ethernet frame, but before going there, let us see that the data link layer has the type value, which is the identifier which says what is the next type of header in the packet. In this diagram, you can see this is the type value, which is a 2-byte value. So you can see in this diagram it is the Ethernet frame or the data link layer header, and there is a field which is a 2-byte field in this header. So this is the type value I have shown you. Similarly, in the IP header, you can see this is the protocol field here. It is this protocol field which says that what is the next type of header in the packet. Is it a UDP header? Is it a TCP header? So depending on that, the value of this protocol field is set. Similarly, coming to the transport header, you can see that it is a UDP header format. So UDP header format contains the source port and destination port. It is the destination port which uniquely identifies the application which is listening to the port number running on the machine, and accordingly the transport layer hand over this packet to that application which is listening on this destination port. The same is true with TCP header. In TCP header also you have source port and destination port. So it is the destination port which uniquely identifies the application. So I have shown you in the Ethernet header, in the IP header, and in the transport headers, which is UDP and TCP, that what are the fields which identifies the next header in the packet. This is important to know because when the receiving machine receives the packet, it has to read the content of the packet. And in order to read the content of the packet, every header must indicate that what is the next type of header in the packet, right? Then only you can read the next header. Otherwise, if you don't know what is the next type of header, how will you going to read it? It will be, without knowing the next type of header, it will be a just random piece of bits and bytes in the packet, and you can't read it. So it is for this reason that every header contains the information which says what is the next type of header in the packet. Now, coming back to the Ethernet frame, you can see that the structure of the Ethernet frame on the screen. So preamble is actually a physical layer concept, and preamble is actually used to indicate the start of a packet. So it is not of much importance to us. We will discuss the destination MAC address. So you can see that in the Ethernet frame, the first relevant field is the destination MAC address, which is a 6-byte address. The next field is a source MAC address, which is again a 6-byte address, because MAC addresses are of 6 bytes. Then type field I have already explained. It is a 2-byte field. Then the rest of the data which is carried inside the data link layer packet has a size ranging from 46 bytes to a maximum of 1500 bytes. Ethernet packet is also called frame. So when we call a packet, So a packet operating on a data link layer is called a frame, L2 frame. So minimum size of the L2 frame is 46 bytes and the maximum size is 1500 bytes. Now it's an exercise for you to figure out and browse the internet and try to understand that why the maximum size of the Ethernet frame is kept as 1500 bytes. Why it cannot be more than this? And why the minimum size of the Ethernet frame is 46 bytes? Why it cannot be less than this? So it forms a great interview question. So it's a homework for you that you figure out why. Now the destination address is a 6-byte address I have explained, and the source address is again 6-byte MAC address. Then type is the identifier field. So 080, if the type value is 0800, it means that the next header following in the packet is the IP header. And similarly, if the value is 0041, then the next header, that is after the data link header, that the next header following in the packet is the IPv6 header. Similarly, if the type value is 0806, it means that the next header following in the packet is the ARP header. That means it is a ARP packet. So info means the payload data, that is this info. So rest of the data that is carried in the packet is called a payload. And then the last field is a checksum. The receiving machine checks this value to indicate that, to verify whether the packet has been corrupted or not. So again, it is out of the scope of the syllabus. You can read it about checksum on the internet or from standard books. Now let us take an example of how L2 routing is done. So as I have already told you that L2 routing is done from one machine to another machine within a subnet. Note the word within. Now let us see this example. Suppose E wants to send packet. Again, when we are discussing L2 routing, then the packets are called as frames. So it is a terminology. So let E wants to send packet to D. So E prepares the packet, and how it will prepare the packet? It will prepare the Ethernet header. In this Ethernet header, the source YMD, because it wants to send a packet to the machine D, and the receiving interface of the machine D is IFD, which has a MAC address MD. And the source MAC address that the machine E will fill in the packet is ME, that is the MAC address of the interface through which the packet will transmit out. So this is the destination MAC address and this is the source MAC address. After it has prepared the Ethernet header completely, of course it will fill the other fields in the Ethernet header. I am not discussing that. I am discussing only the destination MAC address and source MAC address. After it has filled all the fields of Ethernet header and the following headers, it will place the packet on the wire. When the packet is placed on the wire, the packet will be received by all the machines connected to the wire. So in this case, the packet will be received by machine D, by machine F, and by router also. So remember, whenever a machine places a packet on the wire, the packet is received by all the machines which is connected to the wire, right? But only the machine D accepts the packet. Why? Because the destination MAC address specified in the packet is equal to the MAC address of the receiving interface. When this condition is true, then the machine accepts the packet. So when E transmits the packet on the wire, the packet is received by all other remaining machines connected to the wire. When other machine receives the packet, they check. So what is the condition? They check if destination MAC is equal to MAC of the receiving interface. Now this condition is true only in case of machine D in our example. So that is why only machine D will going to accept the packet and it will promote the packet to L3 layer of the TCP/IP stack, that is the network layer. So what does the machine D do? It chops off the Ethernet header, that is, it removes the Ethernet header and hand over the rest of the packet to the network layer. If the condition, that is the destination MAC, is not equal to MAC of the receiving interface becomes true, then receiving machine discards the packet. So it means that the machine F as well as the L3 router will going to discard the packet because the destination MAC that is specified in the packet is not equal to the MAC address of the receiving interface. So this is how L2 routing is done, that is the machine E is able to send the packet to the intended destination D. But now there are some questions that must be popping out. So as I said, D accepts the packet, but F rejects the packet. Router also receives the packet but rejects it since destination MAC address specified in the packet is not equal to MR, where MR is the MAC address of the router interface. So this is how L2 routing is done based only on MAC address. So have we used IP address anywhere? No. Right? The machine E is able to send the packet to machine D based on MAC addresses only. Now there must be some questions. How E would know D's MAC address? This is the first question. How E would know that it has to send the packet to the machine D, but machine D is connected to the wire with the interface whose MAC address is MD. How E will know this knowledge? Do you think that other machines on the wire, in this case the F, is unnecessarily disturbed for the packet not destined to it? This is called thrashing. For example, let's say machine E is continuously sending the data which is destined to machine D. Right? So machine E is continuously sending the stream of packets which is destined to machine D. All those packets are also heard, or we can say overheard, by machine F as well as the router itself. But both the machines, that is the router F as well as the machine F as well as the router will going to reject the packet as per the criteria. So they are unnecessarily disturbed for the packet not destined to it, and this is called thrashing. It means that the two machines in the subnet are communicating with each other, but other machines are unnecessarily burdened with the packet, and those machines receives this packet only to reject it because the MAC address specified in the packet is not equal to the MAC address of the receiving interface. So to solve these two problems, we have address resolution protocol called ARP, and the second problem is resolved by L2 switch. So remember, this problem is solved by L2 switch and routing is done by L3 router. So students often get confused that what is the difference between a router and a switch. So router is this device which works at the network layer and its purpose is L3 routing, that is routing a packet from one subnet to another subnet, whereas switch is a L2 layer device. And we will discuss in detail the functionality of the switch, then you will going to understand clearly and differentiate between the switch and the router. Switch versus router, and it forms a famous interview question.